Hello guys, welcome back to my channel, Tech Boy. So in this video, I would like to talk about compressor simulations. In specific, is about the rating of the compressor simulations. Um, so what makes it different? In rating simulation, we will have a more rigorous compressor rather than a simple one because we are supplying the compressor curve data. So here, let's jump to the simulation. I have a compressor curve sample, yeah, that have the information for the speed of the compressor and then the flow respecting to the head and the efficiency. And this is what we are going to supply to the simulation software. In this case, it's UniSim design. This curve, it is extracted from the compressor datasheet. Yeah, this data is a very common one. Yeah, it will be available in the compressor datasheet, so you can refer to that document. So I have extracted a sample of the compressor curve, and I will use this as a simulation compressor curve. Okay, so I will use H2O water as the fluids. I use as my steam fluid package for this. Okay, I will specify steam in saturated vapor at 5 bar example. I will have 3000 kg per hour of steam. Okay, something like this. And then I will install compressor. Steam in and steam out. And stream is W compressor. Okay. So in the design mode, design simulation of the compressor, usually we are specifying two things: the adiabatic efficiency, which is a default value of 75%. The second one is either the pressure increase, pressure ratio, or the outlet pressure. So if we specify 1000 kPa, yeah, it is fully specified, yeah, and simulation is running because the compressor have enough information to solve. But what is the problem with this? If we manipulate the flow, yeah, there's nothing changed here with the outlet pressure as well as the outlet temperature. Okay, so the pressure and temperature is always constant because we in the case of pressure we specify what is the outlet pressure, so it will not be changed. Same here, if I specify the pressure ratio, for example, 1.3, if I change the mass flow, nothing happen. Okay. In the real plant, if the compressor is already operating, of course, this phenomena doesn't occur. Okay, so how to incorporate that relationship between flow to the head and to the efficiency of the compressor is by using the compressor curve. Okay, so I will delete this pressure ratio, and also I will delete this efficiency, because if you see from the compressor curve, we are getting the head and efficiency value responding or respective to each flow. So these two variables will be calculated. Okay, the next thing, I will move to the rating tab. I will add a curve, 1000 RPM curve. First, I will specify the speed as 5000 RPM. Even though you have a single curve For the compressor, you still need to specify the speed. Okay, then I can just copy and paste. Make sure the unit is correct. The volume flow is at actual meter cubic per hour. The head is in meter, while the efficiency is in percent. Like this. Yeah. The curve input type, we have it as a head unit rather than the pressure ratio. Okay, submit change. We have one curve now. I will add another curve for 7,000. Okay, submit change. And the last one for 9,000 RPM. The next thing, I will activate the curve, and I will use enable curve for steady state. Why the simulation is not yet confirmed? Because we don't yet specify the speed of the compressor. Because we have a multi-speed compressor, yeah, we need to specify at what speed we will operate the compressor. For example, I will use the lowest one, 8,000 RPM. Yeah. After we supplied the speed, the simulation converts. Now I will show the pressure value for that because it is the variable of interest at this compressor. Okay, now watch me if I specify the mass flow differently. Yeah, it will affect the outlet pressure. Okay. Yeah. And you will see also here the temperature is also affected. Okay, now let me change back to 3,000. And then if I specify another speed, it will also change this outlet pressure. Of course, if we increase the speed, the pressure outlet or the head will be bigger. Okay, so it is the case for the multi-speed compressor. If we only have one curve, you could see that we are not required to specify the speed because there are no options to select. But if we have a multiple, we need to specify where. Another interesting feature is the plot curve. Yeah, yeah. So we could see where is the position of our operating point. Here, the operating point you see is marked by the red dot. So we could know whether our flow is okay or not. Is it nearby the search curve or not? Yeah, we could see at this head curve. And it is very, very useful also at the dynamic because we could see the progression of the compressor. Okay, if I change, for example, to 7,000 RPM, you could see that I am run here, 9,000 RPM. Here. Okay, we'll change back to 4,000. Okay, so that's it. You could try it yourself with your own sample compressor curve, with your own case. This simulation is forming very useful, especially when you're having evaluation case for the compressor. Okay, so I hope this video helps for you, and See you at the next episode. Bye bye.